drawing Lewis structures and counting valence electrons. Count up the number of valence electrons in an atom. Okay, so in order to determine the number of valence electrons, we need to look at which group that element is in. Okay, so I'll have a picture of that on the next slide. But first, we're just going to go through these steps. So first, you determine the number of valence electrons for each main group element, and for these, you're also going to count up the number of atoms of each type of element in that molecule. Okay, so after we determine the number of valence electrons for each atom, then we're going to add them all together to get a total number of valence electrons. And that is what we are going to use to complete octets around each of the atoms in the molecule. Alright, so here is the way that you determine how many valence electrons. And so the periodic table is very, very helpful with this. Alright, so every element in group 1, so anything in the first column, has one valence electron. Okay? And anything in the second column has two valence electrons. So this is group 2. So group 2 has two valence electrons. Alright? Let's go over to group 3. So boron, aluminum, gallium, all those guys have three valence electrons. Anything in group 4, which includes carbon, we're going to see a lot of carbon, silicon, germanium, those have four valence electrons. Nitrogen, phosphorus, arsenic, 5 valence electrons in group 5. 6 valence electrons for oxygen, sulfur, selenium, and 7 valence electrons for fluorine, chlorine, bromine, etc. Iodine is down here. Alright, and then 8 valence electrons for the noble gas column. We're not going to see noble gases in compounds very often, perhaps one or two in certain molecular shapes, but they're not very stable, so we're not going to see a lot of that. Okay, so these are just a set of steps that you use to draw Lewis structures. And of course, we're going to be focusing on very simple molecules. Molecules that are much more complex, you'll be given the structure for those. So the first thing you want to do is look at the formula for that molecule, and you want to count up all the valence electrons contributed by all of the atoms in the molecule. And then you're going to do something called establishing atomic connectivity. And all that means is you're going to connect them together with a line that represents two electrons. So most of the time the central atom is going to be indicated, and then you just link everything to that, or you'll be given some sort of connectivity, which means it just shows you how everything is stuck together, but all the electrons haven't been added to the structure. So in other words, it's not quite a complete Lewis structure. Now, after you finish step 1, where you've counted up all of your valence electrons, then what you're going to do, and also once you've established how it's supposed to be connected, then you're going to actually connect those adjacent atoms with electron pair bonds. And so basically this is just a line that represents two electrons. So we'll see that in just a second. You'll be able to count up how many electrons you've used at that point. I'll demonstrate that with an example in just a few minutes. So after you do that, you're going to add lone pairs to complete octets. So remember, octet means 8, and that'll be on all of the outer atoms. Alright? Okay, so if we still have electrons left over after every outer atom has 8 electrons, then we're going to add any remaining electrons to the central atom. And finally, we're going to move electrons to obtain octets, if possible. And so sometimes we may form multiple bonds. But again, this is something that we will not go into deeply in this class. Okay, so I really want to stress this. All the Lewis structure drawings in Chem 125 will be simple molecules. And so larger molecules, you'll have the structure given. Okay, so here's an example. So what we're going to do is we're going to draw a Lewis structure for something called chloromethane. Alright? And carbon is the central atom in this molecule. Alright? So what we're going to do is we want to add up all of the valence electrons. So carbon has 4 valence electrons. Alright? So we go up here, there's carbon, so he's taken care of. And then each of these hydrogens has 1 valence electron. So you notice that this 3 subscript means that there are 3 hydrogens, right? And then chlorine has 7 valence electrons. It's in group 7. So now we're just going to add them up. So 4 plus 3 plus 7 is 14 valence electrons. Now, we were told that carbon is the central atom, so we're going to take the rest of these atoms and we're just going to connect them to the central atom with a line. All right? Now, each line it uses 2 electrons. All right? So 2, 4, 6, 8 electrons have been used so far. So we have 14 total. We've used 8. So we've already counted these. So we're going to say 10. So there's one lone pair. 12, another lone pair, and 14 around chlorine. Now, notice that I didn't put anything around hydrogen. That's because hydrogen is happy with 2 electrons. So this bond, that's enough for him. Hydrogen will never, ever have lone pairs. So just this bond. You're going to see this a lot in organic structures especially, where you just have a 2-electron bond, and hydrogen is completely happy. And so we've used up all 14 electrons. We have no remaining electrons, so the step 5 that deals with moving electrons around to obtain octets is irrelevant. We don't need it. Now, let's just make sure everybody knows how to count up how many electrons each atom has. So we have 2 electrons in the bond. That's 2, 4, 6, 8 around chlorine. Okay? So now, the interesting thing about Lewis structures is that we get to count these bonds twice. So even though we counted the bond for chlorine for its 8 electrons, we also get to count it for carbon. So 2, 4, 6, 8 electrons for carbon. And of course hydrogen is happy with 2. Alright, so about drawing Lewis structures, the very, very best way is to practice. Okay, so use the guidelines and practice. And there are many practice problems on sapling and also in problem sets and solutions in the text. Make sure that you find those and that you practice them. And once you get the hang of it, you'll actually think it's pretty fun, I hope.